Hi all, my name is Johnny. Today I am going to present my project on microwave oven control system using a big microcontroller. This project demonstrates how embedded systems are used in real life home appliances. Next is content of presentation. This presentation is divided into several parts. First, I will explain what an embedded system is and its components. Then I will discuss microcontrollers, embedded C, and application. After that, I will explain my project, its architecture, and simulation. Next is what is an embedded system? An embedded system is combination of hardware and software designed to perform a specific task. Unlike a general purpose computer, an embedded system is dedicated to one function. It consists of processor, memory, input-output devices. And the examples of the embedded system are washing machine, microwave oven, traffic light system. Components of embedded system. The main components of an embedded system are processors, microcontrollers, a memory, input devices, and output devices. The processor controls the system. Memory stores the program. Input devices accept user input and output devices display or perform actions. All these components work together to complete a specific task. Next is microprocessors and microcontroller comparison. A microprocessor contains only the CPU and required external memory and peripherals. A microcontroller integrates CPU, memory, and peripherals on a single chip. A microcontroller are small, cheap, and consume less power, which makes ideal for embedded system. Next is comparison of microprocessors and microcontroller. Microcontrollers offer better integration, lower cost, lower power consumption. Therefore, microcontrollers are widely used in embedded applications like home appliances and industrial control system. Next is why embedded C is used in checksum. Embedded C is widely used because it provides fast execution and direct hardware control. It uses less memory and portable across different microcontrollers. It is also an industrial standard language used in most embedded system applications. Next is applications of embedded system. Embedded systems are used in many fields such as GPS system, medical devices, automotive system, ATMs, defense and aerospace, home appliances, and banking sector. Our project is an example of embedded system used in home appliances. Next is what is a microwave oven? A microwave oven is used to heat food using electromagnetic waves. It contains a component called a magnetron which generate microwaves. Embedded system controls the timing, mode selection, and safety operations of a microwave oven. Next is microwave oven mode. The microwave oven operates in different modes. First one is micro mode, which is used for normal cooking with maximum power of 900 watts. Next is grill mode, which is used for cooking meat and bread. Here, user can set time accordingly. Next is convection mode, which allows preheating. It is about 60-second need for preheating. After the preheating, user can set time for cooking. Next is start mode, which is used for quick heating for 30 seconds. Next is the requirement of our project. This project requires knowledge of embedded C and tools like MPLAB X IDE, MPLAB XC8 compiler, and PixSimLab. It also required understanding of CLCD, matrix keypad interrupts, and GPIO interfacing architecture. Here we use X16F877A microcontroller. It has 40 pins with multiple GPIOs, timers, and interrupt features. It is suitable for learning and implementing embedded projects. Here we use keypads. The keypad which is provided provide user input to microcontroller. The microcontroller processes the input and controls output such as LCD display, fan, and LED. This architecture shows how input processing and output are interconnected. Next is CLCD. CLCD stands for Character Liquid Crystal Display. It is used to display message and system status. There are two types, 16 group 2 and 16 group 4 display. Communication can be done using 4-bit or 8-bit mode. Next is matrix keypad. Matrix keypad used arrow and column arrangement to detect key cluster. It reduces the number of microcontroller pins required. It is commonly used in calculator, telephone, and digital logs. Next is interrupt. An interrupt is a mechanism that allows a device to request immediate attention from the CPU. When an interrupt occurs, the CPU stop current execution and jump to an interrupt service routine. After servicing, it resumes normal operation. ISR, which means interrupt service routine. An interrupt allows the microcontroller to respond immediately to an important event. When an interrupt occurs, the microcontroller pauses the main program and jump to a special routine called interrupt service routine. The interrupt service routine is a short and fast routine that handles specific events such as timer overflow or a key press. After completing the required task and clearing the interrupt, the microcontroller returns to the main program and continues execution. The ISR is essential in real-time system because it ensures quick and accurate response. Next, timers. Timers are hardware module used to measure time, interval, and generate delays. They are used for scheduling tasks, event counting, and time-based interrupts. In this project, timers helps to control cooking time. Next is tools required for this project. PixSimLab, which is used for simulation purpose. And next is MPLab XIDE, which is used for coding the project. And next is MPLab XC8 compiler, which is used to convert embedded C code into machine code. These tools helps to test the project before hardware implementation. Next is project demo. This is MPLAB XIDE, which is a software which is used for coding our micro project. Here, these are the headers which are used in this project, and the header files which is used to interface each and every components to our microcontroller. Here, by using the file like CLC.h file, which is used to interface each pin to the microcontroller. And the next is bold file. These are the closed files that are used in this project. Here in this main.c, which is basically used for calling all the functions that are related to this project and various initialization of global variables which are done in main.c. And the other files like microoven.c, timer.c, isr.c, clcd.c, these files which are basically used for definition of each and every function. Next, we can move to the simulation section of our project. It's SimLab software which is used for simulation of our project. Here we can see in this board our microcontroller PIC16 F877A and its peripherals. Here we can see matrix keypad, CLCD display, cooling fan, and various other peripherals. Here, we need to power on this this board for simulation of our project. Then we need to load our hexadecimal file. Then we can see the display shows the powering of our microwave oven. Then we can see the menu. First, we are doing micro mode. For do cook in micro mode, we need to first enter one. So it shows the power 900 watts. Then we can see the field to set time for cooking. Here we adding 9 seconds for cooking. Please enter. When we need to go, we can press 5. Then by pressing 4, it will be 0. Then still cooking mode is grill mode. For entering to grill mode, we need to press 2. Here first we need to enter the time of cooking. And 2 seconds. We will stop by pressing 6. Then it will return to mode selection menu. And then we can cook in conversion mode. For that we need to press 3. Here in conversion mode we need to enter the temperature. So I am entering 150 and pressing done. In conversion mode, there will be there need 16 seconds to preheat the oven. After that, we can set the time of cooking. We can set the time. And then 30 seconds. One cooking. Start mode. For entering into start mode, we need to press 4. In the start mode, will initially set 30 seconds for quick heating of the food. If we need more time for heating, we can press 4. By pressing 4, the time of cooking is incremented by 30 seconds. If we need to pause, we can press 5. Then press 4 to resume. We can stop cooking by pressing 6. These are all about our micro oven project. Thank you.